Wonder if it's gonna pop up with that window like it does. Should. I might just have to do my own way here. Add source, window capture. Which one is it? 2? Aha, look at that. So I have a record of this going on. Trim, I think, was one of these commands. Alt. There it is. Look at that. I don't think I usually have anything going on the top right corner. Just so I have a record of that going on. So today I'm gonna look at another motherboard with the power connector broken off, or the battery connector. I think the only really theory that I can guess that people are doing is that when they try to take this connector off to remove the power board, they grab onto the ends of these connectors, maybe with a pair of pliers or something, and just rip the whole thing off. Like just grabbing it on the side and just yanking it off, instead of knowing that it's a male-female connection. Oh. So this one does look like it has the prongs still on it, so I can reuse this connector. Yeah, I can see the prongs on it. I don't know why that last one didn't have the prongs. I think I just chucked it in my junk pile, because I really don't know if I can do anything with that connector. I was gonna see if I could maybe take out the prongs. Like, do these things come out? And what I mean by that is there's tiny little copper contacts on the end. Because if these kind of slide out, then if I ever come across one of these connectors that's mangled... Oh, they do slide out, okay. If I ever come across one that's mangled, then I can just replace it, because I have the housing, or this little female connector piece, just not the little prongs that are in it. This one does, so I can recycle it. I did want to try something, though. The last motherboard that I worked on, it had a faulty charging circuit due to something, or component U11 was grounding for some reason. I don't know if it faulted at some point, maybe it suffered a surge, I wouldn't know. I couldn't really begin to theorize, but what I can do is at least see if the charging circuit is at least somewhat intact. I don't actually know what's going to happen if I try plugging it in without the main power connector attached. Hopefully it will do something. Okay, good. So that is normal behavior. Flashing orange light means that the console can't detect the voltage from the battery. I'm just sort of moving the charger around. Okay, the flashing stopped when I hold the charger like this, which means I need to look at the charge port, possibly reflow those solder joints. I am just going to do a general inspection here. Why did I keep the Wi-Fi board on this? I usually take the Wi-Fi boards off when disassembling consoles just to signify that there's something wrong with this board. But the motherboard looks fine otherwise. What I'm really looking for is just, is there any water damage, corrosion anywhere? Are the little connection points for the ribbon cables, are these little tiny latches still there? A lot of these consoles I take apart for the very first time, so those latches haven't been operated since these things came out of the factory. It's usually when users try to repair them that these little tiny latches get broken off. But yeah, I'll reflow that charge port, and usually it's never just the charge port. For some reason, it's also the fuse and this component up here, EM1. I'm thinking just because this board is it's at the corner of the board, and if something aggressive happens to the charge port, like you drop the console with the charger still inserted, it'll flex the board and break those little solder joints. It doesn't break the components, it just makes those joints a little less reliable. And as you could see, as I was flexing that charge cable, the light would completely turn off as it would break connection. So I'm going to try and do this without scorching the connector. I think it's less scorching the connector. I think just this plastic is very porous, and it just sucks up my solder. Or it sucks up my flux, and I can't really do anything about it. So it's just crispy looking. So let me get my solder iron up. I was gonna do a little bit of touch up there. I might get a little bit of solder paste to put on to those rear contacts. Because there are 4 mounting points, and only the rear 2 matter. The front 2 are just for stability, because it is a plug, so it needs to have some amount of, well, something holding on to the board. Let's see if I got my camera working. Is this one my camera? Yes, it is. Okay. I neglect to rename these devices in OBS so I know what they are. Okay. This little microscope has been very useful, despite it being very cheap. I'm definitely looking for an upgrade at some point. There's the connection point. It actually looks really good. When that connector was ripped off, it didn't tear off the pads or didn't yank up traces, is kind of the most important part. Especially that positive line. It's just that little cluster of 4 vias, which I'm guessing would make it kind of robust as a means of holding down that trace line. I don't think any of the board, like the connector rip, I don't think any of them tore up traces, but I'm going to have to double check. Maybe one of them did. But it's good to see that they're still there, and I can do something with them. So kind of what I wanted to do is I need to get a little bit of water on my solder iron sponge. I just have a giant jug of distilled water right next to me. That should be good. Put this syringe right there. I'm just gonna kind of prep these pads a little. My working area underneath this microscope isn't that great. I might have to go a little hotter. The ground pads on these motherboards just drink heat. A lot more than I would expect on a board this small. Like Like especially, yeah, those ground pads are especially sticky if I don't have my iron up hot enough. Okay, I think that's pretty good. I was gonna add just a touch of solder paste. Actually a touch. Just to put a tiny bit of fresh solder on those 2 pins. And then I should be good to reflow everything. The one on that positive pad might be just a touch too much. Now it kind of looks funky. It almost looks like TV static. Those are tiny, tiny, tiny solder balls suspended in what should be flux. I actually don't know the fluid it's suspended in. Yeah, that should be good. Once I get everything heated up, it should just suck onto those pins. Those pins will have enough real estate to soak up that solder. Make sure it's a really solid connection. I'm not too worried about the 2 pins in the front. Now I'm going to move my camera so I don't melt it, because I'm going to use hot air on the back side. Also have my fume extractor going. So now it's going to be getting this into position. Without smearing that solder paste all over the place. I think I did a pretty good job. I'm gonna have an eye loop that I'll look through. Can be a touch more reliable than a microscope. Okay, yeah, that should suck down to the board really nicely. I'm not gonna... I'll have the heat at 400 degrees. That should be plenty. look at it a little closer. I guess it didn't suck down to the board like I was expecting it to. Perhaps my efforts to bolster up those solder joints was working against me. It is lifted a little. But those joints are on. Gosh darn it. Alright, let me get it cleaned up. So yeah, it isn't the... I don't think it is the flux. I think it's just that the hot air sort of scorches that connector a little. Which isn't... Which I don't think really matters. It's just cosmetic. It's not actually... I don't think it's actually melting the connector. Gonna look at it again. Yeah, it is lifting in the back just a hair. Probably because I added a little too much. Well, it is because I added too much solder, but I'm okay with it. That's not going to impact the console's ability to close. I didn't use that much flux, so I'm just gonna... But the important thing is it's on there pretty solid. See if the connector clicks on nice. Yeah. Clips on there. So it may just be as easy as that. That's all I needed to do to this console. But I will put it together in my test suite. Well, not my test suite, I'll just put it test components on it. See if the thing powers up, sort of what state everything's in, does it charge. So my test components here are just a whole bunch of garbage pieces that still function. Like, these screens have water damage to them, but they still power up. Water damage in my case I just can't use. They're garbage to me. I don't even think I can salvage any parts from them. I just don't have the means of cleaning anything to a clean room standard that I would desire. And then that's a third-party battery, which I probably wouldn't ever sell. My best understanding is third-party batteries do not perform as well as OEM, and I still have a good pile of OEM batteries that I can use. Hey now, you let go. Alright. Battery is inserted, console is still off. I am going to try charging. I have my little USB tester here with a USB to whatever this connector is, DSi, 3DS. No charge. So flashing orange light, console's not detecting the battery. That can sometimes point to... Let me take the battery out before I start doing some probing. That will point down to this little surface-mounted fuse right here. So I'm testing continuity on my multimeter. I'm getting nothing. So this fuse is blown. The connector was broken off the motherboard. It is possible that that caused it to blow. I'm guessing that when those connectors break off, for some reason, it's possible that when I was shipped these consoles, since that connector was just freely flopping about on the motherboard, it's highly possible it touched another component and just sent a surge in one direction or another. In the last one I worked on, it is entirely possible that that was the reason component U11 was shorted to ground. In this one, it's possible that it sent a surge and blew the fuse, which is the most ideal situation, because that's exactly what the fuses are meant to do. So in this case, I'm going to take this off. This is a blown fuse. And I'm going to test it with another one that shouldn't have a blown fuse. And I think I still have a DSi kicking around that something's wrong with the motherboard, that it's just blowing fuses. Hopefully this one's not the case, because I'm not entirely sure why that's happening. This one also blown? No, this one's good. I'll sanity check just to make sure that this one is still blown. And just I didn't fumble my probing. Yeah, I'm getting nothing on that one. Okay. So this one is not blown. So what I'm going to do is plug it in and see what happens. Alright, battery in. I do have to reflow the charge port again. I haven't forgot about that. I'll just do that later. Alright. Solid orange light. I'm getting a power draw. So, fuse on this one's broken. I could deal with it. I have to remember where I put my fuses. So, it charges. So let me disconnect it. And power on the console. Console powers on just fine. Hello, Kelsey. I will delete all the data so random personal photos aren't just blasted. There we go. You can tell that this touchscreen is also not the best, but I just need to come down here. While that's doing that, let's just plug it in while it's on. Yep, power draw, orange light's on. I know, right? Yeah, it was just random person named Kelsey. Same spelling, too, which is kind of strange. But I'd rather not blast people's personal photos on the internet, but considering that the main power connector was broken off, there's no way those photos could have been removed without that connector being fixed. But when people sell me their used consoles without bothering to factory reset them, well, to a degree that's on them. But in this case, there's no way they could have factory reset it without fixing it, so I can't particularly blame them. Well, this is going. Well, no. While this is going, I can't really do anything. I was gonna update my records to say that this motherboard is fixed, but I can't scope the serial number in its current configuration because serial number is on the back. I need to make a little battery holder that will hold the battery in without actually having the entire rear case assembly. I could just cut it up. DSi XL motherboards USA needs repairs. So it'd be somewhere in here. Man, this formatting's taken a long time. I'm not entirely sure why. I do notice that a lot of times when I'm formatting these memories, sometimes it's quick, sometimes it takes a while. I don't know if that's because of a failing EMC or there's just a lot of data on it. I didn't spot what the software version was. I don't know if that has anything to do with how quickly or slowly a console wipes itself. So I'm just going to get the initialization out of the way, because I'm going to have to go through all this anyway. And the touch input's off by like a few centimeters, it feels like. At least a centimeter. There we go. Okay. I'm not going to test anything more on this console. I will reflow the charge port though. And I might go see where I have my fuses to replace the fuse on this power board. Not really the most important. I have plenty of power boards. They're kind of a dime a dozen. They're also very simple, which plays in my favor. I'll move my tester stuff out of the way. I don't necessarily need to remove this power board, but I'm just going to get it out of my way. Alright, before I get way too ahead of myself, let me get this motherboard updated. 05Y, it might be this one right here. 05Y0612 U019231 negative A05. Here it is. Power connector ripped off, assumed good otherwise. Okay. have it on as repaired. Connector is slightly lifted, but otherwise functional. If I want to address that in the future, I can. I don't think it's that big of an issue. It's more cosmetic than anything, since it doesn't impact. There are components around it that are much taller, so it's not gonna work. I don't need to worry about clearance when it comes to closing the shell. And I'll get all that nice and flexed up. I can see if I can get the microscope on. Why not? So the goal is to reflow the charge port, that F1 fuse, as well as component EM1, which I think is like an induction coil. I'm not going to pretend to really understand what exactly it does, but I found that either one or all three of those components, if a solder joint is broken, will interrupt the charging. So, since I'm here, since I have a solder iron, and since I'm flexing everything, I might as well just reflow all three. And I usually try the bolster up, just add a touch more solder onto the charge port itself. Just make a mound. I know there are ways to solder that makes it look good, but this is an internal component. Get my fume extractor going. So I got a nice big blob on that, on the positive side. I need to kind of adjust my angle. I don't want to accidentally melt that connector right there. There we go. That's looking a lot better. I know there's very official, by the books way you're supposed to have solder. I'm not gonna say it's all nonsense, but to a degree. Like, really? Does it really matter? As long as it's not egregious. I don't really see a reason to be so particular. Okay, I don't want to touch that shoulder button connector because it's kind of right in my way, so I need to sort of adjust myself here. Oh, that should do it. A tiny bit more solder on EM1, the F1 fuse, as well as the charge port. So before, when I was flexing that charge Or when I was flexing the charger, the light would go out. Shouldn't do that anymore. Unless I missed it, that charge port is still good. I'm pretty sure I wiggled it. Yeah, so mainly what I'm looking for is if that little tongue, what I unofficially call it, that little plastic tongue in there that holds the pins, it should be rigid. When they break, it flops around and will fall out. That's the one with the blown F1 fuse. So now let me get this all wiped down. Being very careful how I brush, because if I brush too much going backwards, it might yank that little latch off the backlight connector. And that makes for a very bad time. Okay, I'm gonna let that dry for a second. I'm gonna go look for my fuses. Here they are. Okay, exactly where I thought they were. Got these from AliExpress in just big, or chunks, essentially. Just 100 of them. They do the job. Whether or not I trust that they're rated correctly and that they won't allow voltage in to damage the console, can't really say. It's a little out of my area of expertise. Ooh, almost just shotgunned that fuse somewhere. This little guy is so tiny. Alright. Get Mr. Microscope back on. Now the fuse in question is this little fella right here. Has like a checkered pattern on it for probably very technical and specific reasons. Because I don't think that's a common notation for a fuse. This is the DS. I guess I can't really say because I don't necessarily do. I'm not really looking into boards this closely. But I've only ever seen them on DSIs have this checkered pattern. Blah. I add a little bit of solder on my iron just so it can push heat to those two pads. I think I need to clean my iron off, actually. Come on. There we go. Now the AliExpress fuse, which has a big F on it. Now, if you want clear notation, nothing says fuse like a big F. I might try and heat gun this one on, actually. See how that works. I'm actually not really sure. See if I can get it nice and looking nice. And if it's an excuse to practice, I think it's a perfectly valid reason. See if I can get my camera far enough away that I won't melt it more than I already have. The workable distance in front of this microscope's not good, so I have touched it several times with my iron. I don't need it at 400 degrees. I can get definitely away with a much lower temp. Let's see here. Just kiss it with a little more flux. I suppose that works. It definitely didn't behave how I expected it, but it did the job. I think I was expecting something a little more dramatic, like it would be just sucked down into those little solder mounds. But I'll take that. Let me put my microscope aside. While that's cooling down a little, I'll just make sure that either it wasn't faulty or connection's good or the heat didn't break it. Why am I not getting a connection on the negative side? I'm getting connection through the fuse, but... Oh, I thought that sucked on pretty good on both sides. I might just have to touch the negative side. Or touch the downstream end of the fuse. Let me check it. Huh, yeah, that looks pretty good. That's weird. You just keep trying to probe it here. Try and flip this connector over. Get a better angle on that. So it connects right there. Alright, I guess I'll just touch that side with my iron. It's kind of strange, but alright. To my eye, it looks like it's on there pretty good, but voltmeter is saying it isn't. Oh, I'm stupid. Okay, never mind. I'm just real dumb. The fuse doesn't short to negative. Come on. It's a positive. Yeah, okay, I'm good. It's good. I was wondering why the positive wasn't shorting to ground. I think I just have some leftover trauma from yesterday. With that said, let me try and get some of this. When this flux solidifies, it becomes like tar. So I gotta be a little more aggressive with it. Probably my fault because I choose cheap flux, but I don't solder enough in my life to really justify getting like really fancy stuff. Does the job, and that's really all I need it to do. Comes in a form factor I don't mind using, so. Ah, looks nice. Just that little chunk of. Looking pretty. I need to see if I still have that. My notes for this console, I'm just gonna report that I reflowed power. And that I also replaced the F1 fuse on the power board, because I'm just going to keep this power board with the console. They're really interchangeable, but it makes it a lot easier for me to store consoles when I have or store parts when I have them kind of together. Okay. So I will count this as good. I'll just double check the fuse on the board. All this one needed was just the the battery connector resoldered on, and the F1 fuse on the power board replaced. So if the fuse is good, it will short between this point and this test point on the board. Which it does. Neat. And we'll stick that in my good pile. Now, voila. Ooh. Okay, this one I'm not going to be able to do anything with right now. For one particular reason, the connector doesn't have contacts in it. But I think this one is the one that had the ripped traces. Not bad, per se, but definitely not good. Yeah, look at that. Those copper pads are ripped off. So what I can do is I can shave back a little of that solder mask and bridge a wire, or maybe even just enough solder will do the job. The main reason I can't do anything is because it doesn't look like this connector has the contacts in it. The little two copper prongs are ripped off. So I'm not going to say this motherboard's junk, but there's nothing I can do with it right now until I can get another connector. Because I think the junk boards that I have, both the connectors are ripped off. I'm going to take the female end off, though. I'm just going to try and inspect it, but I don't see the contacts there. It's a little hard to do this. Well, no, I can't really fudge it. The only way I can really do this is if I clip the connector off and just solder it straight to the motherboard. I don't want to do that if I don't have to. But that is a method of just solving this problem. Yeah, I don't see it in the connector, and it's missing those two copper contacts. So, oh, look at that. Somebody has done definitely some repairs on this. That is a way to fix the F1 fuse if it's blown and you don't want to buy fuses, but that's a shitload of solder. Jesus Christ. I can fix that at least. Yeah, there really isn't a way I can do this. I'll look at my junk boards again. I'm pretty sure I already used up both of those connectors that I had. And I think you can source these connectors from DigiKey. I don't know, though. Oh, look at that. One of my junk boards does still have its connector. Perfect. So I will be able to fix this. So here's one of my junk boards. This one, well, we're going to get a nice good microscopic look at it. This one just had rampant water damage, rust. I wasn't going to try and deploy this thing. Like, this thing is just bad. The parts are good, but I just don't have the means of cleaning a board like this. You'd really have to put it in an ultrasonic cleaner and just hope for the best. and how much of this is compromised due to just rust, and it might just be fine. Like all of this might just come off, but if that's like eating away at the solder mask, how many vias are compromised because there's just rampant rust? Really, I have no means of assessing that. Like even right there, that little cluster of pads where resistors or components would go, you can see just black in those vias. Those vias could just be completely compromised. But individually, the parts might be fine, but it's just possible the inner traces are just completely eroded away. But that's the part I'm looking for right there. I just so happen to have one left. Thank goodness, because I don't want to make too many junk boards if I don't need to. So, kind of like I was saying, I'll save that little empty connector. I'll just put it in my junk area. I might find a use for it later. So I'm going to get this off. Let me put my camera off to the side. And while I'm thinking about it, I'm going to get the solder off of this fuse. I guess for that I could put the microscope back. So this is like I was saying, this is a method of getting rid of the or fixing the fuse, because these fuses do blow. But what you're doing is you're bypassing a protection circuit, and that is really not the way to do that. You're just asking for trouble. But as just a method of troubleshooting, it is a way to just confirm that everything is good on the motherboard, but oh yeah, look at that. Look at that big blob of solder. And look at that, the fuse is still in there. Buried under all that solder. So I'm going to make the bold assumption that fuse is blown. I'll check it. Try and get this leg soldered back on, just enough to confirm that it is bad. I think it's on there. It's a little hard to say. I'm going to assume that the person doing this hack job knew that this fuse was blown, but I'll double check it. Yeah, that fuse is blown. So I'll do the same as last time and this fuse off. Thankfully there's already a crap load of solder, so this should be pretty easy. There it goes. I should just buy a reel of F1 fuses. Just 1,000 of them, or however much are in a reel. Just for the hell of it. I don't think I'm ever going to go through 100, but just to kind of see what a surface mount component reel looks like would be kind of neat. Those pick and place machines are pretty amazing. Alright, my big F is here. And the flux is very sticky, as it usually is. And when it's sticky, it makes using these small components, or moving around these small components, kind of difficult. Alright, perfect. I'll try heat again to see if that works. I did a pretty good job last time. Just sort of kiss each side with some flex. Omnivice going. Omnivice was a very good investment. A little expensive, but very, very handy. No, where are you going, Fuse? Don't do that. I have to turn down my airflow. I didn't think it was that high, but blowing away. Oh, come on, you know you want to suck down in there. Oh, solder's climbing one leg, climbing the other. You gonna slurp down, or do you need some encouragement? Well, it's definitely not going as well. When in doubt, do it the old-fashioned way. There. Not as pretty as the last one, but should do the job. I get continuity through the fuse. So I am good on that front. Get it nice and cleaned up. Also have to try and take up that old flux that was on there from the previous person too. Don't mean to scrub so intensely, but like I said, when this flux solidifies, it becomes like tar. I don't have to get it all. But it looks nicer when I do. Which is ironic when I say that I don't really care how solder joints look, as long as they do the job. Even though those joints aren't picture perfect, they work, and they are solid. At the end of the day, I think that's really all that matters. It's not creating additional issues. Regardless, I'll get off that soapbox. So now, focus on my junk board and get this connector off. Looks like I just kind of looking at this junk board. I'm guessing I took off this power management chip at one point. I'm not really sure why. I think because I tried diagnosing an issue. like it came off pretty nice, but kind of indiscriminately cooked everything around it, and I just left all the solder there. It's a junk board, doesn't really matter. Get my microscope out of the way. Doesn't matter in the sense that I'm not really worried about this board too much, just the components. This board will never see a boot cycle. Before I get that far, let's do that. Get that up to 400 degrees. I'm going to just try and go exclusively from the bottom. I'm going to try and see if I can make a more picturesque connector. Now I gotta get this ground plane really nice and cooked. There we go. So now I have the connector. Now I need to sort of look at what I want to do. I do need to scrape off some copper and get some solder on these points. Let's see what we got here. Yeah, that's a mess. It's not bad, but how on earth do you do this? This poor console has seen much more than it should. I don't even think I gave this thing a general inspection. Game card pins are good. All of the ribbon cable latches are also good. I don't see anything else wrong with this console. It just fell into somebody's hands. So this ground plane looks pretty good. I need to grab my X-Acto knife. The ground plane's pretty big, so I don't necessarily need to worry about it. The positive end, however, is going to be a little more challenging, because I only have that little cluster of vias to work with. It's a pretty large space, in actuality, that's quite a bit of space for me to work with, compared to a lot of trace jobs I've seen. Doesn't make it no less challenging. So I kind of want to go right here and just scrape off some of this solder mask. I'm gonna be kind of liberal in how much I expose, just to make sure I have a nice good landing spot. Silkscreen marking is pretty tough. I'll ignore it. That should be good. That's a good landing spot. It's positive, however, I need to be careful not to do that and scratch the negative, because I don't want to bridge solder onto the negative. Oopsie, that's going to cause troubles for me, I suppose. If I can just get this big flake right here. Okay, I'm just gonna have to be very careful. Thankfully, I kind of know what I'm doing, so I'll be able to check if it's shorting to ground. Should probably double check that just to make sure I don't go on a wild goose chase for the U11 component again. Okay, let me look through my eye loop at this. Should be good. I might try and get a little more of that positive end. No, I think that'll be okay. It's enough exposed for me to work with. Grab my solder paste again. I'll be able to control how much solder I put on. I'll need to be a little more liberal with my solder paste because I'm putting them on, or basically making new pads. Some paper towel hair is stuck on them. That paper towel hair is making things very difficult for me. Try and get it off. Oh, mamma mia. There. That'll be enough to work with. Now I have to determine whether or not I want to try and run a wire. I think the only problem I have with that is it's going to be kind of hard to keep that wire in place. I do have some pretty thick wire that I can use. This should be a good gauge. think this is 20. I don't remember what gauge it was. Kind of check here. Yeah, and then what I can do is just have the wire end just sort of poke out, and then I can edge cut it later. Because I'm guessing I'm just going to need that little tiny helping hand to reach over to those pads. Or I could just bolster up these little artificial pads a little more and then maybe push the connector back a little further to try and get it to grab onto these new pads that I'm making. I'll clean it up just to see what it looks like. I should probably make sure that positive isn't bridging. It doesn't look like it is, so I think I'm okay on that front. Yeah, I'm thinking I'm gonna probably need this wire. That's looking good. I like that. Ooh, that's looking good too. This connector is definitely not going to sit on flush, but this is just going to have to be how it is. It's trace repair after all, so it's not going to be OEM naturally. Get the edge cut off this little excess that's dangling off. And I think I'm ready to try and install this now. It's going to be a little difficult, because there's nothing really stopping these wires from just falling off. It's not really something I can do after the fact. I have to sort of do that prep right now. Also won't really be able to do this with the microscope. What I can do is see kind of what it looks like in the back. I have it, I think, in the right spot. It looks like it will grab onto the positive. If I nudge it over, I might be able to have it. It might grab onto the negative. Yeah, I'm just gonna have to see what that does. It's a little hard to say. I'm guessing these wires are probably gonna come loose. So I'll try and tape them down. Okay, well, here goes nothing. You know what? I could probably microscope it. And get my fume extractor a lot closer. I don't know if these front two pins are going to mount. They're a little far away. As long as they mount just a little bit. The wire is lifting, kind of what I expected it to do. Come on, baby. I might need more solder on the end of that negative wire. I don't think it's going to grab on without me torching the top of this connector, which I was trying not to do. Oh, it's doing something. Settling in. Leave it for just a couple more seconds. Doesn't really look like that positive end is liquefying, kind of what I expected. Come on, baby. Looks like the negative liquefied really nicely, though. Try and concentrate more heat along the vias. There we go. That's exactly what I wanted it to do. 3, 2, 1. Okay. That looked pretty good. I don't think it grabbed on. I don't think the negative grabbed onto that leg. I'll do continuity tests, of course, but I might have to sort of sneak some solder paste in there and then just remelt everything. Okay, I'm on continuity on my multimeter. This will be a little hard because I don't know how loose this connector is either. Yep, it's not connected to the negative. The positive is connected to the negative either, thank goodness. So I'm going to have to sort of worm in some solder paste in there. The positive connected. No, it's not connected either. I don't think. Oh, the positive is connected. Okay. Try the negative one more time just to make sure it wasn't a false negative. Nothing. Alright. Yeah, I didn't think. It didn't look like it was connected. It looks like it's sort of balling up right there where I cut back on the solder, or the solder mask. But it sort of balls up there and stops. It doesn't go all the way to the connector. So try and see if I can get a sharper angle just to kind of see. It's a little hard to tell, actually. But I'm going to trust my multimeter. I'm going to try and sneak a little bit of solder paste in there. I'm going to need to turn my board and sort of do this a little off to the side here. This will hopefully put a little more usable solder right where I want it. Try and get that angle again because that was rather useful. Okay. A little more flux, that will sort of go down as I heat everything. There we go. Now we're talking. Ah. Stay. So those little solder balls should all solidify when it gets nice and warm. Ooh, nice and good. What I might do is try and push down on this connector just a touch. See if I can encourage it to go down. Okay. Doesn't really look like anything changed. But I do have continuity on my negative now. Okay. Fantastic. Let's get it down. I'm going to clean it up. And then I'll check continuity on everything. But it looks like it did a pretty good job, actually. Guessing just that just that tiny little bit of solder paste was all that was needed. Yeah, this connector is really gummed up. Now, isopropyl alcohol will dissolve this flux, but when it solidifies, it really doesn't. There's only so much it can do. Where's my favorite toothbrush? Here it is. Oh, I put my flux twisty on my solder. Oh well. I try to control how much that solder paste gets, or where that solder paste goes. Not exactly stuff I want just dabbing on everything. I think it's lead free, but lead free solder, okay. If it was leaded, oof. Just liquid death. Right, favorite toothbrush. Definitely gonna have to get in those nooks and crannies. And you know what? It actually did a lot. It did pretty good going in from the back. I was able to solidify it without torching the connector, so good to know. That I should know that. What I didn't think is that these two copper contacts would get hot enough just from the bottom, because when I'm installing these connectors, those two copper contact points are just floating. And if they weren't getting warm, they weren't gonna grab onto the solder that I was trying to flow underneath them. But I guess my concerns were not realistic, as it's very clear that they get hot enough to grab onto the solder that's underneath them. Oh, that looks so pretty. Welcome back to the land of the living, DSI. I never did check to see if the positive and the negative shorted together before doing this. Oh well, too late now. I'll tackle any problems that come. So let me check the positive. I know this one's good. Still good. And it is not shorting with the negative. Check the negative. Good. And it's not shorting with the positive. So that is a successful... I think calling it trace repair might give it way too much credit. It was just replacing a pad. So now it's going to be the fun job of trying to edge cut these as close as I can. This doesn't have to be perfect. Alright. And then the negative one I didn't really get a good bite on, but I should just be able to fatigue it off. I was able to like nip it a little bit, but it didn't come completely off. Just sort of bending it like that to fatigue it. There we go. And I'll put these in my scrap wire pile because for exactly points like this when I need just a little piece of wire. Darn good stuff that solid core wire is. Now I'm gonna have to just get it nice and clean again and make sure that that positive line isn't shorting. It looks like it's contained within the little cluster of vias. But I just need to make sure that I don't have a positive line just touching another pad. I'd rather not send 3.7 volts to where it's not expecting 3.7 volts. Yep, it looks like that entire wire is over that cluster of vias where the positive line is, so even if that solder mask does get worn away somehow, it will still be on the positive plane. And the negative plane I'm not worried about because that wire is over the entire negative plane. I'm gonna kind of clean up a little. My little garbage pile is getting a little cumbersome. Using a little air puffer to dry up that alcohol. It looks pretty good, all things considered. I'm very pleased with how that turned out. So now we get to actually seeing if that was all. If that was all that was needed, or if there's any more issues with this console since, well, the fuse was bridged, pads were ripped off the battery connector. Let's just say if there's an additional power problem, then I can't necessarily say I'm surprised. But I'm holding out hope. The ribbon in. What I will do is test it with the charger again to see if I get a blinking orange light. This should fit in with no problem. Yeah, the connector is lifted, but again, that is to be expected. I have wire underneath it to bridge those points. All right. So let me put my charger in it, just see if I get orange blinking light, and that should at least assess that most of this charge circuit is good. There it goes. Cool. Let's grab my tester stuff. Maybe we can see the identity of the maniac who worked on this console. I'm assuming it wasn't them. Well, it couldn't. It's possible it isn't them that did it. Oh, I need a Wi-Fi card. Here we are. I'll have to grab a Wi-Fi card to put on. There will be a time where I accidentally fatigue this ribbon cable to the point to where the display will just be dead. Well, it'll clip traces in the ribbon cable and functionally killing the display. If that happens, this is kind of a garbage display, so it's not too big of a deal. All right, let's check the charge circuit. Will it charge the battery? Looks like I need to reflow the charge port, but it is charging the battery. It's a solid orange light. All right. Blue power light. All right, Matt. Console is alive again. So let me check to see if the software indicator for the charge is working. And it is. Up there in the top right corner. Alright, let's get this thing wiped. I really need to put a functional... Oh, parental locked. Not a problem. There is a website that I can use. That'll provide me the master key. This is mkeygenerator.salthacks.org, or it's just mkey.salthacks.org. What I do is I plug in my device type. I need to change the system date. Let me calibrate the touchscreen so I'm not like losing my mind trying to off-center touch. Okay, so I need to put it as today's date. So 11/19 2025. So now I'll go over to this touchscreen's still bad. I think the quadrant over here is dead. I forgot. Now I have the inquiry number, which is 153496001. With the date, the device, and the inquiry number, it will spit out the master key, which is 95271. Clear settings. To the people who figured this out, how to do that, bless them. Because that would make my job a lot more difficult if I had parental locked consoles. And this console's running 1.4U, which is my understanding, the earliest software revision of the DSi XL. While this is going, I can put my junk board away. Move my camera a little. This is my tester power board. I'll just put that back in my tester box. Wait for this to finish formatting. I'll go through initialization, and then I'll move on to the next board. I will see if I can find the document for this motherboard. I don't have the serial number. I'll have to wait. Ooh, I'm just kind of thumbing through my notes that I have on my other to fix consoles. I have some interesting ones. Like a FE00. Because if one of the main, if the NAND chip is bad, I have my junk boards still have eMMCs on them. I don't know if I can just put an eMMC from another board onto it without, like, are they married? At this point, it's like, I wouldn't lose anything by doing that. They are BGA chips. I would have to sort of fumble around to see if my solder balls are big enough. But that will definitely be an interesting fix, because I do have some experience with BGA chips working on a PS4 that I ultimately wasn't able to fix. So I feel fairly confident that I could do that repair. An eEMC would be great. I wonder how well that would work. All right, my message is closed bracket. All right, so I just need to reflow the charge port and the downstream components to make that connection solid, and then I will assume that's good. I need to grab a Wi-Fi board so I don't accidentally send this Wi-Fi board with it. Because the Wi-Fi boards are my sort of way of indicating that these consoles need repairs. I thankfully have a small baggie full of them. Usually they're just hot swappable, but I know that there are some cases where you can't just put any old Wi-Fi board in without it causing issues. Alright, so let's get everything reflowed up here. Making sure my little ribbon cable latches are down so I don't accidentally pop them off. Now I should be able to get the microscope going again. Get it angled up far enough. There we go. Let me actually put it underneath my mat so I don't accidentally bump it. Yeah, the factory solder joints just on the charge port just always looked weak to me. There's no solder, it's just soldered right underneath the leg and just a tiny bit on top. I guess that's within Nintendo's standards, or maybe just soldering standards, but I never thought it was enough. So again, I'm going to reflow both the charge port, the fuse, and all of the legs on component EM1. And I think, again, is an induction coil of some type. Well, it's a literal coil of wire. What exactly it does is a little beyond my understanding. But what this should do in practice is not only bolster up those joints, but it will eliminate the issue of the charger cutting out when I wiggle the charge cable. Now that's a solder joint. Grab a little more solder. I'm gonna have to come at this at a different angle. Man, those ground planes are son of a bitch. Get in there a little more. We should be good. That should be good. Go around back so I don't hit the shoulder button connector. Ah, touch my light switch. Alright. That'll do it on that one. Okay. And again, in practice, what that will do is now, when I put the charging in, it won't cut out randomly when I jiggle the charger around. It is blinking. It's supposed to do that. So, this console motherboard is good. Let me grab the serial number here. 13806. It's probably this one. 012 U015D7A42. It's this one right here. Power connector ripped off the board, traces for positive and negative ripped off. Perfect. This is it. US SIRS running version 1.4U. No issues. Repaired. Power connector ripped off. Power connector replaced. And trace pads repaired with wire. F1 fuse on power board. Replaced. Charge port F1 and EM1 reflowed. Wonderful. So that will go into my good pile of boards. And to round off today, I'm going to look at one more board, same issue. But it could be I can't do anything with this board, or I can. And it looks like I can. So here's another board. Power connector ripped off, but as you can see, the little copper traces, little copper contacts for the female connector are still there. So I can indeed repair this board. Let me give it a general inspection. Check the charger, make sure the little tongue is good. The pins for the game card slot are all nice and straight. They aren't bent up. Ribbon cable connectors look good as well. They're all there. I'm going to actually preemptively look up this board just to see. I'm the only thing is I wasn't able to assess anything else about this board because I'm not able to power it. But it is 12 70612 U0185JV A25. Lifted power connector is the only notes I have for it. Okay. So let's get this off. Nothing funky with the F1 fuse. This one should be a pretty easy repair. I think I'm getting pretty good at this. Alright. Pads look pretty good. So all I really need to do is just add a little bit of flux. I'll be a little more conservative with my flux this time. And then try and see if I can put this on. Put this connector on without charring it like a marshmallow. Okay, that's good. I'm no pick and place machine, but I think I got it pretty close. I'll turn my camera on it. All right. Ooh, my camera setup is kind of in the way. Let me adjust. I am winning, Lace. I got lucky with these connectors. Because these were ripped off the board, and usually those... Well, I can't say usually, but there's a chance that those little copper prongs go with it, and then those copper prongs end up disappearing. And I don't have any replacements for them. So thankfully, when those connectors were ripped off, those copper prongs stayed. So now I'm just reattaching it. Hopefully, it will go smoothly. So far, so good. Oh, there's one. There's two. And I guess the pads up front are probably solidified. Or are they liquefied? was very smooth. Perfect. The first 3 or so of these that I did, I ended up sort of cooking those little connectors, charring them like marshmallows. Not necessarily intentionally, but more of a lack of experience. Like here's one I did. Like it doesn't hurt the connector at all, but definitely doesn't look that great. It's more cosmetic. It still functions. So that one went on pretty good. Very good, in fact. Especially since I didn't melt it. Alright, I dare say that was pretty good. Definitely not perfectly center, but looks like the solder is grabbing onto those legs. Alright, I think I'm good to actually start testing this thing. Was this my tester power board? I think it was. No, this wasn't. This was the power board that was with it. Yeah. Okay. I'm gonna grab some tester components. I'll start by just plugging it back in. Then putting the charger on it to see if I get a blinking orange light. Ooh, so this is one of those consoles where the orange light is on for a second, then turns off. This is a newer revision board. I still don't know exactly what that symptom means. I don't even know if it isn't a symptom. It could just be normal. But that light should be blinking, not just on for a second, then off. Let me get some screens attached. We can see what Mad Lad ripped off the power connector. Because they weren't able to factory reset their console. Alright, so let's see if it charges. Battery is in. Blinking. So that is probably a fuse. Check it on the power board here. Curious. Fuse is good. See if it powers on. Okay, so this is one of these issues that I'm gonna have to look into more. Probably study a schematic. Wow, that was weird. I thought that said Killy loves you. I'm like, oh, huh? Almost had a weird existential crisis. Get that formatted. So what I can do... So this is an issue I think I have documented that I haven't solved. So it's not drawing any power. Charge light's blinking. Let me look at my notes that I have. I just have a giant, massive sheet of problems that I've been sort of curating. Let me see what notes I have on this device or on this problem while it's factory resetting. No charge light. Oh, I know I have notes on this issue. Where did I put them? So that's related. The console doesn't power up. This is a charging issue. Orange light flashes, powers up and plays. My current theoretical is a faulty battery, which I know that's not true. Curious. Okay. I have something I can try. I can try reflowing the charge port EM1 and F1. It could just be as simple as that. That the connection isn't good enough. I'll see if I can just kind of jiggle it around and see if I get a connection, if I get any power draw at all. According to my USB tester, I'm just getting nothing. It could also be the I didn't check the battery connector contacts. I never checked continuity for them. Obviously, the console turns on, so both of those connections should be good. Let me go through initialization for this console just so I don't have to worry about it later. No, not J. Really need to put a better touchscreen on this junk screen. Well, I think the touchscreen's fine. I think it's just off center. Alright. I know that battery's not bad. I don't really care about this screen, so I'll just sort of yank up the touchscreen. Try and center it a little better. That should be a little nicer to me. Alright, let's get the screens off. I don't need the Wi-Fi card in order to test charging. Alright, so the only thing I can think of is there's something wrong up there. Up here on the the intake for the charger. Let's get a good looky at it. That fuse shouldn't be blown because there wouldn't be a charge light at all if that fuse was blown. I can check it anyway. Because I know there's some like really weird problems that sort of masquerade as other components but end up being the fuse when it shouldn't be the fuse. Fuse is fine. So I'm just going to reflow all of those points and check again. As it could be just like maybe the solder joint isn't completely broken, but like just enough is hanging on that a little bit of, I guess I shouldn't be just spouting theories, but I'll just see what happens after this. Flux it up. And then if this doesn't do anything, I'm going to have to sort of come back at this at another day so that I can put more time into it. Because I'm going to need, I'll just have to study the schematic to see kind of what might be the problem. Compare it with a known good board and see if maybe it's just a fault in component U11. If it is a fault in component U11, I'm kind of boned because I don't have any more U11, or I don't have any more junk boards. Okay, that should do it. Reflowed everything, added a touch more solder to everything as well. Like, I wonder if it's like a grounding issue. Like, maybe the positive line is in correctly, if the ground isn't. Yeah, I can't help but speculate a little. Alright, so let me check the... see if it charges now. I don't need any of the components plugged in order to check to see if it will charge the battery. Interesting. So we're blinking again. Or still. How much time do I have? Oh, I have about 5 minutes. Okay. Let me just sort of look at it just for a second. Let me change out charging boards. Or the power boards to just see if there's an issue with the power board itself. I'm gonna look at the ribbon cable. Ribbon cable looks fine. Here's the power board from my testing unit, which I know works. The power boards are simple, so I almost never suspect it. There are cases where the ribbon cable will become corroded, and that can cause some issues, but you can visibly see that, like, oh, this one's corroded. Where the symptom that I'm showing right now is not going to be as simple. Nothing. Okay. Well, let me start probing around the usual, or potentially usual suspect, Mr. U11. Now, this did not... Okay. So, let's see what I got here. So these two bottom legs should short to positive. Pin 9 and 10. Am I on the positive? And they're not. My probe ends might be a little fluxy from all the stuff I've been doing. Let me just clean them off. Go back on the positive pad and check pin 9 and 10. I'm not getting anything. Why aren't I getting anything? So I should be able to... I should have continuity to these two pins. So I think that's why the circuit is saying, hey, there's no charge coming in. Or it can't detect... Well, it can detect the battery, it's just not allowing a charge. Trying to see... scratch off if there's like a little bit of clear coating on there or something. I'm getting nothing. Let me touch the battery connector on a different spot. Curious. Okay. So what I understand is it should just be an open line from the battery connector to this leg. Like I can't even get it on this side of the capacitor either. That should be the positive line. Let me just check this leg with ground. Okay. It's not shorting the ground. I should be able to see that in the power connector if it was shorting the ground. So I don't know why that's not shorting over like that. Let me plug in the battery connector. Maybe the vias are corroded? I think the problem with this is a multi-layer board. It has to be. Like, there's really no rational explanation as to why this isn't. Because of just how the positive contacts are sort of clustered and terminate. Which shouldn't really be possible. Where is it? Right there. TP7 is the positive point. And that via looks kind of strange. Let me test it with the positive on the power board. Ooh. I'm not getting anything. That is positive. Okay, so this one should be the negative plane, but just by how big it is. Getting continuity. TP7. I'm getting nothing. I'm wondering if that trace or those vias are corroded. Oh, I don't want to spend more time on this, but curiosity is having the better of me. Let me scratch away some of this solder mask. You can tell just kind of right there, it all looks kind of grimy. Now, it seems fairly unlikely that all 4 vias are fouled. But it doesn't look too good. I don't think that was because of mine. The only other option I can think of is maybe I just didn't... That positive connector isn't making a good enough contact. My continuity testing is saying it is. Like, I don't really... So let me just check it again against the, like, actual battery positive contact right here. Let me just try and touch the end, just the little tiny tippy tip of this pad. Yeah, and I'm getting contact. So for some reason, the electricity isn't, or the voltage isn't going through these vias. So what I was thinking of trying is just scraping it away. Hitting it with flux and a little bit of solder and just sort of seeing if I can get it to connect. I might have even thin enough wire that I can just punch through the via and solder on each side. I'm not entirely sure if that would work. But it's something I can try. I'm gonna take this connector off. I need some solder. That's interesting. The solder is telling me that well, I may not have scratched enough of that solder mask off to make a connection to the test point. Try that. If not, I can just blob it all the way over. Oh, really weird. Not that it isn't blobbing over, it's just... I don't know if there was a trace there to the test point. I'll just do something like that. Not an elegant solution. But this is definitely, I'm just sort of winging it here. Seeing if that actually does anything. I heated up that positive plane pretty good. The bump left there by the solder shouldn't impact anything. I'm not too worried about it. There, that's pretty enough. So establishing a link to the test point might not actually mean anything, and I don't even know if that actually was able to do anything. I'll test it here. I'll get it plugged back in. Well, I won't plug it back in, but I'll get the power board back plugged in so I can test the continuity a little easier. So we're going from the positive right here to the test point. I never checked. Yeah, the fuse is good. So now it's testing all the way to my blob of solder again. Let me flip over and go from the positive all the way to U11 again. If I get continuity there, that was my problem. I'm still getting nothing. Huh. Wonder why that is. Because even if component U11 was faulty, I should be able to still detect the positive line. My understanding is the positive line goes directly to it. Let me see if those vias go on the other side. Test point 195, that it is? I have to do some weird testing here. No, I don't know where it goes. I need to check another board, actually. I'll see if I can detect a test pad on the back. So typically, this is a good board. Pin 9 and 10. Short directly the positive. So I need to see if there's a test point on the back that corresponds with this test point. That via right there, or this little cluster of traces. Okay. So there's almost like a rail. This little line right here. The vias punch through, and then they go to this via. So let me see if it is detected at the via. It is. So the positive line is detected right there. It should travel across this via to these two vias right here. These two vias go to the other side of the board. I'm going to double check that before I start scraping and soldering. But all right. So here's the rail again. You can tell those vias look vastly different. This one's nice and shiny. So I'm going to go on test point 7, the one I just soldered. This via right here, I get continuity. This via to these two vias, I get continuity too. So if I had to take a guess, it's these two vias. Let me just look at it again and see if I get... Because, yeah, that one's a lot more dull. I don't think that's like... I don't think the solder mask's bubbling up right there. I think that's just a little bit of crud. Well, maybe it is. So we have that. Let me just confirm that via goes to test point 7. I get continuity. And then all the way to those vias. Yeah, and I'm not getting continuity in those vias. So let me scrape back and see kind of what's going on. It could just be rampant corrosion. Well, rampant corrosion I think is a little hyperbolic. Just corrosion. I'm just going to expose both vias best I can. I can try and see if I can get a needle in there to sort of dig out that solder mask that's in there. But I don't think I have an instrument that sharp and like pointy. This is a sewing needle and like it can only do so much. Okay, so let me check to see if I get continuity from the battery, positive and negative, to these two vias. Curious. So electricity isn't making it to that spot. So maybe this part that I thought was just some gunk. Let me expose that side. Maybe this might be actual corrosion then. Oh, where am I at? Here we are. Or maybe this via just isn't attached. Huh. Okay. Let's keep probing. Because unless I'm completely crazy, this should just be a copper strip. So for them not to have continuity, let me go from the test point to just right on this exposed copper. I'm getting nothing. So This via isn't connecting. So I am going to expose it and dump some solder in there. I am grabbing onto something because I'm able to get a continuity measurement to it. But I have to kind of dunk my probe in that via. So the idea is going to be to just get some solder. I have a little bit of... Let me start fresh with my solder iron here. Get a little bit of solder. Goobered on. Gonna put the heat on there for a good little bit. Try and see if I can really get that via filled. Okay. Let's try that again. So let's go from the positive, or TP7, to here. Still nothing. So I wasn't able to get in there with my iron. I'm gonna have to keep trying. I'll just put the heat on there kind of for just a second, see if I can really get it down in there. Try and scratch at it with the end of my iron. I might not be able to. Okay, I sort of wetted it a little more. Let's try it again. Still nothing. That's kind of wild. Get a little more flux on there. I just have to try and just get solder the flow down into that via. It's interesting as I'm testing resistance, but it's way too high. So I might be getting close, or it's picking up resistance. I'm not looking for resistance. I need basically no resistance. Okay, there, I got the via exposed again. I'm trying to dig in there with my... And see if I can still get continuity from within the via. I can, so I know it's in there. I just gotta... I'm guessing solder mask... Well, no, that doesn't make any sense, because I'm testing continuity. I just gotta maybe scratch away a little more solder mask that's just squatting in there. A little more flux. Yeah, my solder isn't going down into the via. Try and add a little more. Still nothing. This is kind of incredible. What I could try and do is jam a small end of a wire in there. So what I think it's just doing is I think the solder might just be sitting on the surface. It's not actually going in. So I need some type of method of just sort of encouraging the solder to go down. I wonder if that actually poked all the way through. It did. Okay. This actually might work. Oh. Well, I need to just take all of the shielding off. The silicone wrapping. There we go. So what I'm basically doing now, kind of not exactly intentionally, but I think this might be the best method, is just bypassing this via and just making my own. Just gonna be poking a wire through, soldering to the wire. I definitely need some more flux there. I may not even need to solder the other side. I probably will, or just... It just depends on how the vias look. Ah, but that did exactly what I wanted it to do. So if I had to guess, it dragged solder down into the via and was able to connect. So let me look at the other side. So it looks like the positive plane goes right there. I don't know if it actually connects. Is that all just the positive plane? It might be. But let me make sure before I do anything crazy. But I would have no problem, because if this via is just isolated, ooh, it is. It looks like it's just completely isolated. Let me look at the eye loop here. Because if it's just isolated, I'll just flush snip it. And that should be the end of that. I shouldn't have to worry about that anymore. Yeah, it looks like the via is isolated. It did what I needed it to do, so I don't have to do anything fancy. So what I can do here is just flush cut it as low as I can. That shouldn't cause any problems, because it will touch the sides of the vias, which is fine. It just won't touch anything else. So let me flush cut this here. This little bit of wire isn't enough for me to try and save. I have enough spare wire that I don't need to keep every scrap. Okay, and I did test it with the points I scraped off on the other side of this bar, so I know it works. I'm just gonna get this flux off so that we don't have any more corrosion issues. Oop, hit my light switch. Need a Q-tip. I have a few of those. A little sharp. I'm gonna try and see if I can just nip off a little more. There. Okay. So let me do another test here. From the positive of TP7 to this point. Continuity. From my freshly soldered point to the end of this rail, which is right there. Continuity. Now the ultimate test. The battery positive to leg U, or leg 9 and 10 of U11. Perfect. We have continuity all the way from the positive terminal to U11. Now let me get it back together, put the battery in it, and see if it will charge. I first want to try and see if what it will do without a battery. Blinks. Expected behavior. Okay. So the power light coming on then off is not normal. Problem for later. Let's see what happens. Battery is in. Power draw. It is charging the battery. Fantastic. I'm going to add that to my notes. So, I actually can probably bring up my notes here. Yep, right here. So right here I have orange light, charge light flashes, unknown if console turns on. Well, actually, I need to delete that. That's redundant. So, charge console status. I should probably clarify. Does the console turn on? Question mark. Unknown. So that was because the sources didn't specify whether or not the console turned on. Thank you. And then console status powers on and plays. So I'm going to link this video. I feel bad for the poor sucker who will have to, whoopsie, paged up. I'm going to delete this because that's not true. All right, right here. So this is confirmed. Confirmed. In vias. Corrosion in via. I'm just going to sort of pluralize that. I don't know how many vias were corroded. That broke. That broke continuity from the battery plus to leg 9 and 10 of component U11. So the only thing is the power light that turns on then off, but still charges. So this problem right here, not flashing. So I can just add that as a personal story. No, I technically shouldn't have deleted that previous entry. So I'm trying to remember what it was like from yesterday. Kind of what the actual problem was. Add it as a personal story. Had a console with this behavior, but charged, but charged normally. This leads me to believe that it is a oven IC indicator light, but no solid evidence confirms that. But no solid evidence confirms that. A charge was changed to a blinking light on another console that didn't charge when the corrosion in a via, I'll be a little more detailed, via continuity between the battery plus and pin 9 and 10 of U and the 11 was addressed. Had a console with this behavior, but charged normally. This leads me to believe that it is an older revision of an IC, but no solid evidence confirms that a charge light like that was changed to a blinking light on another console. Had this console with this behavior when the battery was out. But charged normally. Charge light was changed to a blinking light when the battery was out. This there could be an issue with that trace. Alright, cool. I really like it when I can bolster up these notes. Okay, console was charging normally. I unplugged it because I don't want to charge that battery to full. It would go against my interests if I charge this battery to full and then had the console reporting a full battery that I misinterpret as a charging issue. No bueno. So I'm going to kind of wrap up here. I'm going to put my X-Acto knives away because I really don't like these things bouncing around and slicing my hand open. I'm just trying to see. I'm just going to look at my little solder jobs that I have here. None of them should be a problem. What I will do is put Kapton tape on them, which is a non-conductive tape. This will just cover up all my little solder blobs. Shouldn't cause any problems, but I'm just better safe than sorry. Now I can get to this console. Look at the serial number. That fella right there. Which I think I already opened it. Yes, I did. Let me just double check. Okay. This is a US console. No known issues. Repaired. Lifted power connector was reinstalled. Charge light blinking. Console turned on. No charge. Erosion in via broke continuity between battery plus and pin 9 and 10 of U11 repaired. Cool. That's this one, right? Making sure I put my motherboard serial number notes in the right spot because I'm moving this one outside of need repairs into the live folder. Okay, I'm gonna go see if I can find that motherboard that I repaired that had a similar issue. It should be this one right here. So let me just confirm it here. So this is one where the battery light, if I recall correctly, this was yesterday, the battery light just turns on, then off. It doesn't blink. The interesting thing about this console, however, is it charges a battery. So this is different from this other console that wasn't charging a battery. If I remember correctly, I don't think it was testing continuity up to U11. So that's going to be my clue to go off of. So let me get U11 highlighted again. Oh, this is the one where I replaced U11. Ignore the scratched away solder mask on the ground plane. It's harmless, just a little ugly. So let me go from the positive physical battery contact to pin 9 and 10. I have continuity to them. Well, that's unfortunate. That's kind of my only clue. So I think the only thing I can really think of is maybe one of these pins aren't attached, which pretty sure they all are. Yeah, they all are. The vias on the back all look good. I did have continuity all the way through them, so I don't really suspect it. Yeah, I have continuity all the way through. Yeah, this is one I don't know. I don't know why the charge light behaves like that, but as far as I can tell, it's harmless. Like, the only thing I can think of is maybe it's just a revision. I think that's just lighting. Yeah. Yeah, I really don't know if, like, maybe one of these resistors on top are bad. But again, it's harmless. The console charges and it powers on. It just, the light behaves like that. I really have no explanation. Because it's not a problem, it's just a quirk, essentially. Trying to see if I can get a resistance reading. These things are so teeny. I think that's 100 kiloohms. 3.2 kiloohms. 100 kiloohms. I don't know. Like, is it really worth probing into why that happens when it is harmless? Not really. I shouldn't spend more time and resources on a not problem that is sometimes a problem. So that's why it sort of leads me to believe that that light turning on then off is just a different manifestation of the blinking light. I think the only... I'm going to try something. I have a little baggie of power boards. A lot of them are fine, but they just have a broken F1 fuse. I'm gonna find one that specifically says some of them are missing buttons. I know I wrote F1 on a few of them. A lot of them were just like, needs an F1 fuse. I have enough power boards kicking around that are in good shape, so if I really need a power board, I can just replace the F1 fuse and go about my day. All buttons bad. That's an interesting one. Ooh, that one's really gross. I guess I don't have good notes on these. Let me see if I can find one then. Just running continuity on random ones. Oh, and I'm lucky. Okay. First one was a fuse. And if it ever gets to the point to where I need to start reaching into this bag of junk to repair the fuses to use, then I have them, just in case. So I don't expect an outcome to be different here, but what I'm going to do... trade out the power board with one that has a blown fuse. I'm going to plug it in with a battery. It won't charge, but I need to know what's going to happen with the charge light. Alright. On, then off. What's interesting is it pulls for just like a second. Okay, let's remove the battery. On, then off. So it's not blinking, I'm just pulling it back out, and it was reconnecting. So this is just a quirk that I haven't quite nailed down. It's not a problem, I don't think, but that's not normal behavior, is sort of what I get at. That it's not supposed to just turn on and off like that. It's supposed to blink, but... I think the only way I can really nail this down is when I start working on DSIs. Those are much older consoles, relatively speaking, than the DSi XL. The DSi XL came out later than the in the DSi's life as sort of like a midway or like a optional revision, essentially. I believe I have it in this console's notes that it does, the charge light does do that. But yeah, it's charging normally. So I don't know why the charge light behaves like that. Anyway, I went about an hour longer than I was expecting, but I did solve another issue, which I am very pleased with the outcome, that it was a VIA. So that implies that the line coming from the positive charge port going up to U11 is critical into the charge circuit. So I'm very pleased to be sort of armed with that information, as that should help me diagnose charge issues in the future. I know I have several motherboards that just have weird charging issues that I was never able to fully address because I just didn't know. Now I feel like I know a little better. So I hope that I can, well, get at that a lot better. Anyway, I'm going to call that good.